Hello there. My name remains Oladapo, and I welcome you to the Global Tutor virtual class. Still on my class on electronic configuration. In my last video class, I showed you how you can write the electronic configuration of element number 11 to element number 20, showing you how orbitals overlap, that is overlapping of orbitals. And I believe I've been able to show you how you can write the electronic configuration of elements. Now, like I told you in the last video class, that there are some possible questions that examiners can ask you, just giving you the electronic configuration of an element. Now, what are these possible questions? Let us run through them. Giving you the electronic configuration of an element, examiner can ask you the number of electron. Examiner can ask you the number of proton. Examiner can ask you atomic number of the element. Examiner can ask you the valency shell of the element. Examiner can ask you the valency electron of the element. Examiner can ask you the type of the ion formed by the element. Examiner can ask you the combining power of the element. Examiner can ask you the group to which the elements belong in the periodic table. Examiner can ask you the period to which the element belong in the periodic table. And examiner can ask you the number of unpaired electrons in the element. And examiner can ask you the type of compound form or even the chemical formula of the compound form when it's combined with other elements. These are the possible questions that examiners can ask you, just giving you the electronic configuration of an element. Let's now consider an example and see how we can answer all these questions. Example: I give you an element and I call it element X. And I say the electronic configuration is 1x2, 2x2, 2p6, 3x2. I give you another element Y and I say the electronic configuration is 1x2, 2x2, 2p5. I now ask you all these questions. I want you to determine the number of electrons, determine the number of protons, tell me the atomic number, tell me the valency shell, tell me the valency electron, tell me the type of the ion it forms, tell me the combining power, tell me the group to which it belongs in the periodic table, tell me the period to which it belongs in the periodic table, tell me the number of unpaired electron it has, and tell me the chemical formula of the compound formed between X and Y. That is what we want to answer. Let us start like this. Roman figure 1. We want to see number of, we want to see number of electron in X and then in Y. Now, for us to see the number of electron, we need to remember I said the power or index or exponent of orbital signifies the number of electron. So for X now, this is the number of electron, this plus this plus this and plus this. So if we do that, we have 2 plus 2, 4 plus 6, 10 plus 2, 12. So number of electron is 12. For Y, 2 plus 2, that's 4, plus 5, that is 9. So the number of electrons for X is 12, for Y is 9. So we have answered the first question. The second question, number of proton, number of proton for X, then for Y. Now, in our knowledge of atom, we know that atoms are electrically neutral because the number of proton is always equal to the number of electron. Anytime that there is a difference in number of electron and proton, ions are formed. But in this case, these are neutral atoms. So it means the number of electrons will also be the same as the number of proton. So you can repeat the answer to the first one. So number of proton here will also be 12. Number of proton here will also be 9. Would also be 9. Would also be 9. So you have 9. Then number 3. Number 3. Number 3 says we should find atomic number. Now, by definition, atomic number is the number of proton in the nucleus of an atom. So it means for X, the atomic number will be equal to the number of proton S possess. So S has what? 12. So atomic number for X will be 12. And atomic number for Y would be 9, because atomic number is the number of proton in the nucleus of an atom. So that answered the question. Atomic number for X is 12 and for Y is 9. Let us continue. Let us continue. Number 4. Number 4. Valency shell. Let us treat valency shell and valency electron together. Valency shell and valency electron together. So we want to treat number 4, valency shell. Valency shell for X, for Y. Now, what do we call valency shell? Valency shell simply means the outermost shell. So let us go to the question. We have one shell, shell 1, shell 2, and we have shell 3. Of these 3 shells, 1, 2, 3, which is the outermost? 3. So for X, the valency shell will be 3. Shell 3. For Y, let us go for Y. We have 2 shells there, shell 1 and shell 2. So of these 2, which one is the outermost? 2. So the valency shell for Y is shell 2. So you have shell 2. Now, question number 5 is asking us for valency electron. Valency electron for X and then for Y. Now, valency electron means the number of electrons in the valency shell. Or you say valency electron is the number of electrons in the outermost shell. But we just said the outermost shell is the valency shell. So the number of electrons in the valency shell becomes valency electron. Now, the valency shell for X is 3. How many electrons are there? That's these 2. For Y, it is this shell, shell 2, shell 2. How many electrons here? 2. How many electrons here? 5. 2 plus 5, 7. So you can come down and say valency electron for X would be 2 electron and for Y would be 7 electron. That is how you answer valency electron. That is how you answer valency electron. So let us see what is question 6. Question 6 is type of ion form. Okay. Now, how do we determine the type of ion it forms? You determine the type of ion, X form and Y form, by getting their valency electron. Now, the valency electron for X is 2 electron. Now, note something. The outermost electron or the valency of an electron of atom can be 1, 2, 3, 4, 5, 6, 7, 8. Now, if you have 8, then you are stable as an atom. So this atom here is stable because it has 8. We call it octet stability. But you see, the one that has 1 is not stable. So it's ready to lose this 1, ready to lose 1 to form plus 1. This one is ready to lose 2 to form plus 2. This one is ready to lose 3 to form plus 3. This one is not ready to lose, is not ready to gain, is ready to what? To share. This one is ready to gain 3 to form minus 3. This one is ready to gain 2 to form minus 2. This one is ready to gain 1 to form minus 1. This can be best explained in another class, but for the purpose of this topic, just get this insight about it, that the valency electron can be 1, 2, 3, 4, 5, 6, 7, 8, and the one that has number 8 is already octet stable. The one that has 1 is ready to lose 1, forming plus 1. The one that has 2 is ready to lose 2, forming plus 2. The one that has 3 ready to lose 3, forming plus 3. The one that has 4 is not ready to lose, neither is it ready to gain. It's only ready to what? To share, only ready to share. The one that has 5 is ready to gain 3, minus 3. The one that has 6 is ready to gain 2, minus 2. The one that has 7 is ready to gain 1, minus 1. So with this explanation, if you look at it, X has 2 electrons, so it's ready to what? To lose. So X will form X2 plus. Y has 7 electrons, meaning Y is ready to gain, so Y will form Y minus. So these are the ions formed by X and Y respectively from my explanation. That is the type of ion form. So number 7, first question there, combining power, combining power. Now, first you need to know the meaning of combining power before you determine the combining power of X and Y. What is combining power? It is almost the same as what I just explained, but it has its own definition. Combining power is the number of electrons that an atom is ready to lose or gain or share for it to obey the octet rule or for it to be stable. The number of electrons an atom is ready to lose, gain, or shared for the atom to obey the octet rule. That is what we call combining power. So if you look at it for X, the valency electron is 2. For Y, the valency electron is 7. So meaning X is ready to lose 2. So meaning the combining power is plus 2. And Y is ready to gain 1, meaning the combining power is minus 1. So the one that is ready to lose 2, the combining power becomes plus 2. The one that is ready to gain 1, the combining power becomes minus 1. That is how to answer combining power. Number 8. Number 8. Group in the periodic table. Now, the group to which group in periodic table. The group to which an element belongs in the periodic table is always equal to its valency electron. So if you look at it, what is the valency electron for X? Valency electron for X is 2. So meaning X belongs to what? Group 2. The valency electron for Y is 7, meaning Y belongs to group 7. So the group to which an element belongs in the periodic table equals its valency electron. For X, it is 2. For Y, it is 7. The next question is period in the periodic table. That's number 9. Period in the periodic table. Period in the periodic table. Period in periodic table for X and for Y. Now, the period to which an element belongs in the periodic table equals its valency shell. So let's go. What's the valency shell for X? The valency shell for X is shell 3. For Y, the valency shell is shell 2, meaning X belongs to period 3 and Y belongs to period 2. The valency shell and the valency shell. That is the answer to that. Let us consider number 10, the number of unpaired electron. Now, for us to answer this question of number of unpaired electron, you need to understand this principle, though it's a borrowed topic here. You need to look at this topic under quantum number, but let us borrow it. You need to understand this topic called HUND'S rule of multiplicity. HUND'S rule of multiplicity. You need to understand HUND'S rule of multiplicity. And what does HUND'S rule of multiplicity tells us? HUND'S rule of multiplicity tells us that you fill electron singly into all the available orbital before filling the pair. That's what the rule is telling us, that you normally put electron into all the available orbital in a singular way. Then you come back to fill their pair. Let me explain it with this example. If you have a p orbital, it has 4 electrons. You have a d orbital, it has 7 electrons. You have another p orbital, it has 5 electrons. Now, you have x orbital, it has 2 electrons. Let us now see how HUND'S rule of multiplicity is explained. Now, there are only 3 types of p. So you have this. There are 5 types of d. So you have this. One, two, three, four, 5. There are 3 types of p. So you have this. There is only 1 type of x. So you have this. Now, the rule says you fill electrons singly into all the available orbital before you fill the pair. So you have 4 electrons. So you have 1, 2, 3, 4. This is the correct way to fill electron. It will have been wrong for you to do it like this. Say you have P, you have 3 types of P. You now say 1, 2, 3, 4. This is wrong. You fill electrons singly into all the available orbital, then you come to fill their pair. For this D that has 7, 1, 2, 3, 4, 5, 6, 7. That is HUND'S rule of multiplicity. For this P that has 5, 1, 2, 3, 4, 5. That is obeying HUND'S rule of multiplicity. For this S that has 2, 1, 2. So if you look at it now, how many electrons are unpaired here? 0. How many electrons are unpaired here? 1. How many electrons are unpaired here? 3. How many electrons are unpaired here? 2. That is how HUND'S rule of multiplicity is explained. Let us now go back to our question. Now, you have 3x2. You have 2p5. So how many electrons are unpaired? For x, you're going to have 1, 2. So the answer is 0. For y, For Y, you're going to have the last is 2p5. So you have 1, 2, 3, 4, 5. So how many electrons are unpaired? 1. So the answer, the number of unpaired electrons for Y is 1. The number of unpaired electrons for X is 0. That answers the question number 10, number of unpaired electrons. Then the last question is the chemical formula formed between X and Y. Before I answer the last question, let me quickly remind you of this. I have a chemistry textbook, O-level chemistry calculations. It is available in PDF form, and initially I was selling for 2,000 naira, but now you can buy it for 1,000 naira, and it is available at this website, the globaltutors.com.ng. Once you visit this site, you will see this book. Just click download and you pay 1,000 naira via Paystack, and you are able to download this book and read on your mobile device. It is a very good book for chemistry calculation. Everything O-level chemistry calculation is in this book. So download this book via the globaltutor.com.ng. Just 1,000 naira only. Let us continue with our class. We want to answer the last question that says the compound formed between X and Y. Don't also forget to like our video, share our video, and follow our page. Thank you. Like our page and follow our page. Now, what will be the compound formed between X and Y? Go back. What type of ion are formed between X for X and Y? X form X2 plus, Y form Y minus. So you come here, the compound form will be X form X2 plus, Y form Y minus. So the ratio of combination will be 2:1, meaning for every 2 electrons lost by X, 2 atoms of Y would come to pair with it. So the compound form will be what? XY2. The ratio of combination is 2:1. This one is ready to lose 2. This one is ready to lose 1. So the ratio to gain 1 rather. So the ratio is 2:1. And if you want to write the compound, it will be XY2, meaning every 2 electrons lost by atom of X, 2 atoms of Y gaining 1 each will come to form a bond with it. So the compound is XY2, and this is what? An electrovalent compound. Is an electrovalent compound because there is losing of electron and gaining of electron. And this will bring us to the close of this video class. I've been able to show you with example how you can answer all the possible questions, just giving you the electronic configuration of an element. So long, success. See you in my next video class.